Today we're calibrating a high-volume air sampler on loan to us from Virginia Institute of Marine Science. I'm going to get all the parts together. This is the spot where the rectangular air filter will actually go. Inside of here, you can't see it, but there are actually two polyurethane foam plugs put in series. This little pin has to plug the port over here on the side, the hose clamp, and fasten it on. It doesn't need to be snug, it just needs to keep that hole plugged. I'll take that back. Let's go ahead and make it snug. Okay? You can't see it from here, but what we're doing is actually connecting this part onto the blue pump. You need an O-ring to go in between there. Bolts out of the way so you can fit down in there. And once the O-ring's in place, you can go ahead and tighten the filter head onto the pump, so you know these bolts are in the way. Tell you what we're going to do. We're going to go ahead and connect the calibration kit to keep those bolts out of the way. This is part of the calibration kit, the top part. You're going to basically turn this dial on top, which closes the opening at the bottom sequentially. So the idea is to measure how much of a drawdown you get as you close this valve on the top. This is the top part of the calibration kit. We're going to go ahead and connect it to where the filter head, where the glass fiber filter will go. shouldn't be making that sound, but that bolt is stripped a little bit. Okay, the wing nuts are on tight, snug.
So, alright, it should be easy to get this filter head on here now that those nuts are out of the way.
Okay, so you should have a seal all the way through. Between this portion and this portion. Alright, now this particular unit has been leaking graphite, so previous people who use this set up this exhaust port so that any graphite coming out of the engine could actually go far away from the air sample. It will mess up your sampler, or your sample, if you have graphite. And then there is a hole here for another hose to do the same thing. That hose has a hose clamp on it. We'll extend this out this way also, away from the sample. Okay, the next thing we need to do is hook up the manometers. There are two manometers to hook up. There is what's called a slack manometer, which has the green fluid. And the way I've been attaching this on here is I just use a kib or twist tie and put it through one of these holes in the frame. So it doesn't fall. Should be able to stand on there, rest on there very easily. Twist tie just ensures it doesn't fall off. That's one manometer, slack manometer as it's called. And you're eventually going to measure displacement of fluid on both sides of the manometer. See that green, that fluid is going to get displaced on both sides. And you want to measure both the displacement on the right side and the left side and add them together. The other manometer you need is this one, and we're going to connect this one. You set this one down here. The tubing down, the opening at the motor down here connects to the red manometer, and the opening to the calibration kit unit goes to the green manometer. Make sure that both your manometers actually have the valve set open. You're getting flow through air through the whole system. You should have your slack manometer zeroed. So zero that so that both sides of the fluid are reading 0. And you should have the same level of fluid on either side. Alright, the bottom of the meniscus on both sides is at 0. Alright, what we have to do now is basically plug in both manometers, turn on the unit, and then we're going to gradually close this valve. There's an open position and a closed position. And as we change that, we're going to measure the change in pressure drop in both manometers. This manometer needs to be secured, so I've been doing that with a piece of tubing. By the way, this red fluid is an actual oil, so be very careful with it. You don't want it to spill. Keep this manometer upright as much as possible. This isn't going to, putting this on top of the other manometer isn't going to affect it. We're not putting any pressure on this latch manometer. And you don't need to see the fluid level down there. Okay, this manometer, the red one, the meniscus is at 2. Let's go ahead and turn the unit on and see what happens as far as pressure drop. The valve is wide open right now. You want to take recordings of those values in a notebook, and then you want to change the opening on top of the calibration unit and take another recording, and so on and so forth for several points. And that's how you calibrate your manometer, or how you calibrate your air sampling. The goal is to eventually, when you go out in the field, to take your air sampler, plug it in, and get the reading on the red manometer only. So what you're going to do is go out in the field, with the red manometer, and you're going to measure that pressure drop in your red manometer throughout your sampling. So you're going to take a reading at the very beginning when you put in your puff plugs and your filter. You're going to take a reading with the red manometer. You're going to come back a few hours later, take another reading, come back a few hours later, take another reading. And what you're trying to do is measure how much the pressure drops as a result of your filter and your polyurethane foam plug clogging up due to particles. That pressure drop, you want to be able to quantify that because you're going to relate that to the amount of air that actually goes through the whole unit. So bring the red manometer out in the field with you. This part here has just been the calibration of the unit, for which you need both the green manometer and the red manometer.